Greetings to all. Myself is Jaslinshin.
I am Sheprendino.
I am Arun.
And we are the Techno Warriors. Our project mainly focuses on India's primary activity, which is farming. Let us start the project. In India, the 60% of the people were belonging to farming. Now the farming get depleted due to the lack of workers. The rover named AgriBot, which helps, which can be used in agriculture instead of farmers. Next is the objectives. In this project, we are using automatic irrigation, automatic seed sowing, soil monitoring, crop monitoring, and flood monitoring, humidity sensor, and etc. First is that design and construction. Using ESP32 IoT, we are controlling the sprinkler, seed sowing, etc. And next is that controlling a vehicle, which means the AgriBot, using local address. Using this local server, which means IP address, we can control the whole AgriBot. In this, it contains 4 tactile buttons, front, back, side. Using that buttons, we can control the motion of the AgriBot. And next is that automatic seed sowing. In the under of the AgriBot, it contains a lid and servo motor. If we use seed on, automatically in the local server, if we give the seed on, automatically the seed sowing gets started. If we give seed off, automatically the seed sowing get off. And next is the automatic irrigation system. If we give seed water on in the local address, automatically the water gets sprinkled in the land. If we give water off, automatically the water gets sprinkled off. The advantage is that it will preserve the water and we can save the water and we can use for the further use. And next part will be continued by my friend Sheprendino.
IoT based monitoring and control. First, soil monitoring. There is a sensor named soil moisture sensor, which will continuously check the moisture level in the soil. And if the condition is so in a dry condition, then it gives a message to our phone. And the sprinkler starts opening and the water comes out through the sprinkler, which is fixed in the AgriBot. Atmospheric temperature and humidity sensor. This uses a humidity sensor and which senses the atmospheric temperature around the field and around the crop, and it also gives us a notification of the amount of temperature present around the crops. Fire detection using smoke sensor. This uses a smoke sensor to detect the presence of fire or a drastic change in temperature. If the temperature is in a high level, then the automatically sprinkler turn on and reduce the temperature by sprinkling of the water throughout the field. Rain, heavy rain and flood monitoring. Here is the rain sensor, which will notify us about the level of water present in the field. It will show that the amount of rain present in the field in a medium rain or heavy rain or in a flood. If so, in a flood condition, the nozzle, this gate will open and the water will be stored for the future use. Next, continued by my friend Arun.
Next, camera-based monitoring. The smart scarecrow. A smart scarecrow identifies the presence of animals and birds. A smart scarecrow identifies the animals. When the animals are identified, the buzzer gets started to produce the sound, which can scare the animals and get out of the field. When the birds are detected, the scarecrow starts to wave his hand and it can scare the birds, so the birds can fly away. Next, identifying the ripe and rough. If the ripe or raw fruits are detected, it can classify that it's a raw fruit or ripe.
And
Components used. We used ESP32, submersible motor, servo motors, Arduino Uno, jumper wires, connectors, the USB32,
etc.
That's it.
And software use. We have used the Synric Pro, Arduino IDE, web browser, and programming language we used is C++, HTML, and block coding.
Where is the web browser?
Web browser, which is the IP address.
Like local server.
Local server.
When you use it?
For controlling the motion of the AgriBot.
As it is an IoT project. compatibility. This agriculture robot will help in the efficiency of labor. Then it will also increase the agriculture yield, and also it will save the cost and risk in mitigation, and also remote farming capabilities.
Implementation and feasibility in the market. It's the next first the precision agriculture. First soil monitoring. If the soil has a dry or it has a water, it can be sensed and it can be water can be sprinkled. So we can save the water. Next, automation, irrigation and seed sowing. If the land has been yielded, the seed can be sowed. So no farmer is needed for that. This can be reduce the cost. Next, crop monitoring and management. If the ripe and raw fruits are, we can see through the camera. If animals and birds are detected.
We can or you do it. It's different. Do you put camera and we can see? Or you will do? It's different. In the future you will put camera to see?
Yeah, we can see.
Okay.
We can see.
We can see?
Yeah.
Okay.
We can classify that it's a ripe or raw fruits. Next, we can see through the camera if any birds and animals are detected. If birds are detected as the scarecrow starts to do it. So. Next, the labor efficiency and the cost reduction. Our agribot is doing the works in the field.
In this
so
sense, which you are watching through the cameras.
Yeah, we can see wherever in the world.
You are watching and taking action according to that.
Yeah. If our agribot is there for doing the works, so no need of farmers. So the cost also be reducing because of the labor.
But you have to activate that.
Yeah.
Can you test?
Yeah. Let us. Now it will show that an elephant is detected.
And the laptop.
I thought I must see the camera application. Let me see.
There is this sheep is not.
How can you use your application?
Yeah, we can implement this camera inside the scarecrow, so that mostly the cameras will be in a Bluetooth or Wi-Fi. We use the USB camera so that we are connecting to the laptop. Otherwise, we could use the Bluetooth or Wi-Fi connection.
The camera? Just. What about the application?
About for the controlling of the robot. Let me show.
So that moisture level is dry because the soil is dry. Also the temperature is 28 degrees. This application we are using only for this field market. For that we are using local server.
Using this local server, we can control the agribot. It contains 4 buttons.
That means we have
Yeah.
how many application that I must use? Camera, PC,
Yeah, 3.
3.
Yeah.
Expensive, very expensive. The application.
You
Why
can-
you didn't try to put it in one application?
Because camera ESP32 cannot be taken. We cannot implement the camera in the ESP. So for the future scope we can be adding any other.
And if you give a friend button, automatically it will come friend. And if you give the pump one,
This is the important. Yes.
if you give the pump one, automatically it will spring it. Now the problem is that relay module not get the enough voltage. Before people were coming, it get voltage had been taken out.
And now,
And for the seed on, if you give automatically under a lid, automatically get on. seeds. Like you can see here, the seeds get narrow. Yeah.
Okay. Okay. Try again.
When I give seed on, automatically down here, this place. Here. Yeah, under this place.
Try. I want to.
Huh?
Try.
Here we need to fill the hole. Then only it will come down. I think now
But it's already open. It's not closed. Look, it's open. Not closed.
now it will close.
Seeds opens.
No.
It's closed now. Okay.
Yeah. When I give, can you take it? Yeah. Now you can. Now you can see it.
I see it.
Seed off.
Connect somebody.
Seeds off.
The thing is that we need to fill all the grains into to fill the hole. Then only it can be perfectly do that.